Good morning. Okay, this is the webex for jim211 Advanced Calculus. Okay. So the webex after intensive course. So during intensive course, okay, we have covered until chapter 16, but we haven't settled. Finished the section for the 16.6. So I would like to repeat this section for 16.6, the absolute extreme. Okay, sorry, the spelling mistake. Okay, the absolute extreme values, then followed by the 16.7, the maxima and minima with side conditions. Then the last section for chapter 16 is the differentials. And if we have time, then we will continue with chapter 17, the multiple integral. Okay, so let's look at that. In 16.5, okay, we learn how to find the local extreme value using the second partial test. And this section, we would like to find the absolute extreme values. When we say absolute extreme values, you need to first determine the local extreme value at the interior point first. Then you need to determine the extreme value at the boundary. Because absolute maximum or minimum, not only we look at local maximum, local minimum, but also the value at the boundary. So, in order to solve these questions, because we involve the functions in x and y, so when we want to evaluate at the boundary points, we need to transform. We need to transform the two variables into one variable. So the easiest way to transform from two variables to one variable is to use the to write it in vector form. Because vector form, you are able to represent one line with two informations, the magnitude and the direction. So this is the formula for if you have a line, you want to parametrization of a line, then you use this formula, so that you can transform a line with two x and y, the variables, into only t. This is a formula for parametrization of a circle. This is for ellipse. And if you have any functions, you may represent x equal to t, and then the functions in terms of t. So the first example we have discussed during intensive course. So I will very quickly I'll repeat this part. Then I will show the example that where you need to. This is a parameterization of a line. And the next example will be the parameterization of a circle. So the exercise 16.6 question 2, this one, since we have discussed during intensive course, I will repeat this very quickly. The questions. This is the questions. We have a function 2x squared plus y squared minus 4x minus 2y plus 2. And then this is the boundary. The boundary. So the question asks us to find the absolute extreme value. If the boundary are not given, we will ask you to find the local extreme value. But if the boundaries are given, then we would like to know what is the absolute extreme values. So the first step is find the local extreme value first. So this is in section 16.5. You find the gradients, the del f del x and del f del y equals to 0. The values of x and y that fulfill this is the stationary point. And this stationary point, you need to determine whether it's a local maximum or local minimum or saddle point by using the second partial test. You find the second partials, okay, the second derivative A, B, and C. Then using the formula D equals to AC minus B squared to know what is the value of D. So D here is equals to 8. Its value is greater than 0. So if greater than 0, then we need to know what is A. A positive, we will have the local minimum. If A negative, we have the local maximum. So in this case, for these functions, the log has only one value, the local minimum, where the value is -1. Since we know that the local, they has a local minimum, then we need to know the boundary, the values at the boundary, the functions evaluate at the boundary. What is the value? Is it greater than -1 or less? So we want to know, because this local may be absolute minimum, it may be it's only local minimum. So we look at the boundary. When we plot this boundary, not plot, okay? So the graph is a triangle region, okay? From 0 to 2, x 0 to 2 means x from 0 to 2. Y from 0 to 2x means y. Okay, this is x0, this is x2. Okay, and then y0 to y2x. 2x is the line. So we have the bounded region. The closed region is a triangular region. So now, this triangular region in coordinates, okay, 0, 0, 2, 0, and 2, 4, and is a function. This is a axis, y equals to 0, the line x equals to 0, x equals to 2, and this is y equals to 2x. So we transform this line into the vector form. And since it is a line, according to just now, the parametrization of a line is, okay, your A, okay, the parametrization of a line. Okay, here, okay, the RT equals to A plus TB. The A is a point, okay, another B point B, and then, okay, the V is actually the direction from A to B. So we take B1 minus A1, B2 minus A2, and T is the parameter. So we denote this as the first line. Okay, transform, take the first point 0, 0 plus T. This is the direction. Take the 2 minus 0, and this is 0 minus 0. So we get 0 plus 2t. Okay, we got the first is 0 plus 2t. The second will be 0. So if we transform into the vector ij, it will be 2ti plus 0j. Okay, then repeat for the second line, R2 and R3. The second line and the R3. All these we transform into the parameter t, where t is 0 to 1. So you may check whether the transformation is correct or not by substitute the values. Okay, for the first line, when I substitute T0, I get 0, 0. This is the first point. When I substitute t equals to 1 into R1, I get 2, 0. So this is this point. So it means this R1 represents this line from the 0, 0 to 2, 0. Okay. Then you may check for R2. It will represent this line. And R3 is the line y equals to 2x. Okay. Then after we get this in t, we substitute this into the functions so that we can evaluate whether the value f at this boundary, okay, does it have the maximum? What is the value? Is the highest point, lowest point, or is in between? Okay, so we substitute. We know the f, the fxy is given as the 2x squared plus y squared minus 4x minus 2y plus 2. So we substitute the first line R1. R1 is 2t0, means x equals to 2t, y equals to 0. So substitute into here. X substitute with 2t, y substitute in 0. Then we get f1 in terms of t, and valid only for t 0 to 1. Substitute R2 into f, you get f2. Okay, so you get f1, f2 in terms of t, and f3 in terms of t, where f3 is, you substitute R3. R3 is x equals to 2 minus 2t, y equals to 4 minus 4t. So substitute into here, you get f3t. So now, f in terms of t only. To find the maximum or minimum, go back to JIM 101. How do you find the max local extreme value? Okay, so we find the critical point by finding the f prime equals to 0. The value that fulfilled is the critical point. This is like in JIM 101. Okay, so is this acceptable? Yes, because it is in between 0 and 1. Okay, and then use the second derivative test. Okay, is a 16. 16 is the greater than 0. You have the local minimum. But what is this value? The local minimum at the boundary here. The value is, okay, when you substitute t 1 over 2 into f1t, we get the value is 0. This is equivalent to f10. Okay, how do we get f10? Is because this is f1t. When t equals to 1 over 2, okay, because this is for f1, so you go to r1t. Our r1t just now is 2t0. 2t and 0. So if t equals to 1 over 2 means we have the 0.10. So this is the local minimum at f10. For the second function, f2, when you do the first derivative test, second derivative test, you notice that this is a minimum, but the value is 1. Okay, and this, okay, because our R2t is 2 and 4t. So when t equals to 1 over 4, that means this is the at the point 2, 1. You have a minimum, the value is 1. For the third one, you will get also the minimum, but the value is negative 2 over 3. Now, you have so many local minimum, local maximum, local minimum. So you combine all the values. What is the value here? Okay, for this one, just now, we obtain F00 here. Okay, so we have combinations. Just now, the F11 is negative 1. we have f10 is 0. We have f21 is 1. We have f2/3, 4/3 is -2/3. So, this 3 is actually, okay, along this point, the 10 is, you have a minimum here. f21 means when you have f2 and then 1 here, you have a local minimum here. When you have f2/3, 4/3 here, -2/3 means somewhere here, 2/3, 4/3, you have a value here, minimum. But there is another point that you need to find is this, the endpoint. So, you need to find f00, f20, and f24. Then compare the value. Which one gives you the maximum? That is absolute maximum. Which one gives you the minimum value? Is the absolute minimum. So when we look at here, the lowest point is -1. So the f11 -1 is the absolute minimum value. The maximum will be this. f24 equals to 10 is the absolute maximum value. Okay, so this we have discussed in the intensive course. So now I would like to show another example which we have the parameterization of circle. The questions, given the functions and the boundary, we would like to find the absolute extreme value. So first, find the local extreme value. Find the del f del x equals to 0, del f del y equals to 0. The value of x that fulfill these two equations, we notice that it's x0 and y0. So that means we have the stationary point at 0, 0. Then find the ABC, the second partial test. We notice that D is the negative value. When D is negative, means this is a saddle point. And remember, saddle point is not the maximum minimum. Okay, so it is not the local extreme value. So there is no local extreme value for this function. Okay, there is no local extreme value at this function. So now we look at the boundary. The boundary is a circle. Interior, the region is over here because less than 4. We have the circle. So according to the vector, the parameterization of a circle is r equals to a cos t, a sin t. This is the x and y, where a is the radius and t, the parameter t from 0 to 2 pi. So, to get because it's only one circle, so you need only one equation that transform the line into a circle. So the R1, R is the a cos t plus a sin t. Okay, you should remember this is equals to, you represent in this form. Okay, it's the same. Okay, this is the same. Put in ij or put in the bracket. So in our case, this is the circle with radius 2. So it's a 2 cos ti plus 2 sin tj. We need to substitute this into, okay, this is 2 cos t, 2 sin t, into the functions, so that we get the functions in terms of t at this boundary. So we substitute into it, simplify, using the trigonometric identities. This will get 4 because cos square t plus sin square t equals to 1. And sin t cos t is actually sin 2t over 2. Okay? Then we get the functions in terms of t. 6 plus 6 sin 2t. T in between 0 and 2 pi. So we need to find f prime, okay, equals to 0. This is back to JIM101. Find the f prime equals to 0. The t that fulfills this is this 4 value. Why we stop until this 4 value? Because we must remember t is in between 0 and 2 pi. If greater than 2 pi, it's not valid. Okay? And then we found that, okay, find the value at this point. You get 12. Find the value at the second point. The value is 0. Find the value at the third point. The value is 12. Find the value at the last point is 0. And don't forget, you need to find also the value at the okay, there is no boundary here. There is no endpoint. So we compare the value here. Okay, so this is 12, 0, 12, 0. So 12 is the maximum, 0 is the minimum. So the absolute, these 2 points will give us the absolute maximum, and these 2 will give us the absolute minimum. But remember, this is in t. F pi over 4 is in t. So for the first line, for this line, for this point, pi over 4, what does it represent in x and y? So we go back to the transformation here. We know that this is 2 cos t for x, 2 sin t for y. So when t equals to pi over 4, you substitute into here 2 cos t, t substitute with pi over 4, we get sec 2. 2 sin t is sec 2, the same. So we get f pi over 4, this is in t, ft, and this is in xy. Is equivalent to f sec 2, and is the maximum 12. So when you do the same thing, substitute pi or 5 pi over 4, you get both negative. If you substitute 3 pi over 4 into this transformation, 1 negative, 1 positive, and the value is 0. So this is the answer. These 2 points will give the absolute maximum, and the value is 12. And these 2 points will give the absolute minimum, and the value is 0. Okay? So this is the absolute maximum, absolute minimum. Now we move on to the next section, 16.7, the maximum and minimum, but with side conditions or constraints. Okay, so remember in 16.5 we find the local extreme value. 16.6 we find the absolute extreme values. Now 16.7 is you find the maximum or minimum, but subject to a side condition. You have one condition that it must depends on the another conditions. We call it g x y equals to 0. So there are 2 methods actually, okay, to find the maximum and minimum with side conditions. The first method, which is most quite popular, is the method of Lagrange. Okay, the formula will be the gradient of f equals to lambda gradient of g, where lambda we call it a Lagrange multiplier. Okay, or you may use also another method called the cross product. The gradient of f, the cross the gradients of g equals to the 0 vector, and these equations, okay, you may get the functions, then you can find the maximum or minimum, which f is related to g. Okay, but for this method, right, the second method here, the computations are quite complicated. It involves the 3 variables. That's why this Lagrange multiplier, okay, is more popular. Okay, let's look at example. Okay, the maximize xy square on the ellipse. B square x square plus a square y square equals to a square b square. Okay, so the first thing we define f and g. Okay, so now we want to maximize what function, what's the function for the one that you want to maximize? The maximize function will be xy square, so it is f. On the ellipse means this is the condition. The condition is gxy. Okay, remember we need to define gxy, then equals to 0. So everything on the right hand side move to the left hand side. So gxy now is b square x square plus a square y square minus a square b square. So I'll show you the example. Okay, how to use the Lagrange multiplier. Okay, so we define this is our fxy, this is gxy. Okay, the method 1, Lagrange multiplier, use the formula gradient f equals to lambda gradient g. So find the gradient of f. The formula for gradient of f, if only two variables, is del f del xi plus del f del y j. If three-dimensional functions, then you have plus del f del z k. Okay? So this is for the gradient of functions g. Find the value is very quite straightforward. Del f del x, assume y constant, we get y square. Del f del y, assume x constant, we get 2xy. And this is gradient of g. Equals these two, and then lambda. Remember? Okay, this is the gradient of f equals to lambda gradient of g. Okay. Then the vector I, we have y square equals to 2b square lambda x. The first equation. Okay. The second equation will be those for j. 2xy equals to 2a square lambda y. So solve for these two equations. We can eliminate lambda. So from equations 1, I get this lambda. From equations 2, I get the lambda. The equation 3 and 4 equals equation 3 equals to equation 4 because both are for lambda. So I get the functions y square equals to 2b square x square over a square. Okay, so after we obtain this, we substitute into the conditions gxy equals to 0. Okay, we substitute the functions into the gxy and equals to 0 the side conditions. So this is gxy. So we substitute y square here. Okay, the y square with this. Okay, this is the y square. Okay, and then solve for it. When we solve, we get x square equals to a square or b square divided by 3b square, and then simplified it, we get x square equals to a square over 3. Okay, so then we can substitute this x square, okay, into, so the x square equals to a square over 3. So when I want to get the x, is because of the square, when we square root, we have plus minus. So we have two values. So if you substitute this x a over 3 into y square here, because this is y square, when you square root, you get plus minus. So it seems that you are going to get, for x positive, you will get 1y positive, y negative. For x negative, you will get also 1 positive and 1 negative. So you have 4 points. First point, second point, third point, and the fourth point. Because of the square here, you are going to have is plus minus. Okay, so x here got plus and minus, y also plus and minus. So this point, which one that gives the maximum? Because you want to maximize the functions at this condition. So you need to find the values for these 4 points. Which one gives you the maximum? Then that is the maximum value. So when you substitute this first point into the f, because you want to maximize xy squared, so you substitute into the f, you get the value. Okay, this gives the same answer, but the other 2 points is negative. But question asks maximize, then the answer will be this. The maximum value is 2/3 over 9, okay, times ab squared. So the one that gives us the maximum is this. Okay, so this is the Lagrange multiplier. You may use the cross product method too here. This method, first method, the Lagrange multiplier, use the formula here to obtain this function. Okay, then you substitute into gxy equals to 0. You may use the cross product. The gradient of f cross the gradient of g equals to 0 vector. Then, if using this method, you will get the same functions. Okay, but for me, okay, I will prefer to use the Lagrange multiplier because this is easier if you have more than one variable. You have functions x, y, z, then this method is easier compared to you need to find the cross product. Okay? So, but you should know that these two methods both will result in the same functions here. Then the next step will be the same. Substitute into gxy, find the xy that fulfill, then substitute into f, which one gives maximum, that means it gives maximize. The minimum value is minimize the functions. Okay, so this is the finding the maximum or minimum with the side conditions. Okay, so 16.7. Now we move on to 16.8, the differentials. Okay, in the JIN 101, right, we find the differentials. Okay, using the formula df equals to f prime h. That means dy dx delta x. Okay, so how to get this formula is, okay, you use the df is actually the difference. Okay, the difference. Okay, we call it differentials, the difference, the df. In the true increment is actually fx plus h minus fx, the delta f. but we can approximate the difference with using the calculus by using the formula this. Okay, so it means, okay, so in the calculus 101, we have the formula f prime x is limit f x plus h minus fx over h approaching 0. Okay, if we didn't write the limit, we just say approximate. Okay, the f x plus h minus fx over h. So the differential is equals to f prime x times h, and we denote this with the df, f prime x dh. Sometimes we write the formula dy dx delta x. This is the differential equation. Okay, this is for functions with one variable. If you have functions with two variables, then the total differential or differential will be, okay, df dx delta x plus del, we use del because more than one variable f, del f del y delta y. It involves the three variables. The differentials, the formula, or sometimes we call it total differentials, will be del f del x delta x plus del f del y delta y plus del f del z delta z. So what does it mean? It means that you can approximate the differential when x or y you have the change, and this change should be small change. Okay, so it means when your x change from this value to another value, let's say 0 and 1, your y, original y, it change to another value of y, your z, the original value, change to another value y, we expect the functions, okay, at this original value will also change from 0 to 1. So df is what is the changes. Approximate using formula, you can approximate the change for the functions. So x change to x1, it can be plus or minus. The y0 change to y1, the difference. Z change to z1, the difference. And we expect the change also happen for f. But instead of substitute the value and minus, we may use formula, we called it the df, the differential, to approximate the delta f. Okay, this is maybe the true difference. This is the approximate the difference. Okay, so you may find and compare the true differential and the approximate differential by using formula. So let's look at this examples. There are okay. This is simple. The exercise 16.8 question 6 is find the differential df for this function. So this is straightforward. Then you just need to find the using the formula. Okay. So the formula for df when involve the two functions, two variables, df, the formula will be del f del x delta x plus del f del y delta y. So when they say find the differential or total differential, since this is not given, you just need to find del f del x and del f del y, substitute into this, then you get the df. Okay, so the problem is how to find the del f del x and del f del y if now you have these functions. So treat this as the product of two functions u and v. So this is the trick that you need to know how to find the differentiation and find the partial derivative. So if fxy uv, so del f del x will be remain u, differentiate v plus remain v, differentiate u. Okay, so this maintain, this maintain. Now, how to find the derivative ln x plus y? When you find the differentiations with x, assume y constant. Okay, so ln the functions, when we differentiate, we get 1 over x plus y. And find the derivative, the differentiation of x plus y with x, we get the value is 1. Okay, so it means ln x plus y is ln, you get 1 over x plus y. Then don't forget to differentiate the inner functions x plus y, because y constant, this is x, so we get this is 1. This is 1 over x plus y, so 1 over x plus y. Okay, plus differentiate this x minus y, differentiate with respect to x, we get 1. Y we assume constant, so y there is 0. So that means the del f del x, I will get x minus y, x plus y, delta x. Oh, no, because we have two parts. So our df will be x minus y, x plus y, plus ln x plus y, delta x, plus find the delta y, the del f del y here. Find the del f del y. So you should get the answer is this. Okay, this is the answer. Okay. Now we move on to this question. Okay, using the differential to find this value. Okay, the question given that z is given, okay, so this is the z. Use the dz, means use the differential. Use the formula to find approximate change in z if x increases from 4 to 4, 1 over 10, that's in 4.1, and y is increased. Increase means plus, so 2 to 2.1, and then compare with the exact change. approximate change compared with the exact change. So the first part, remember this is z in terms of x and y. So our formula dz will be del z del x delta x plus del z del y delta y. What is the del z del x? Z is x minus y, x plus y. So to find del z del x, use the formula u over v. So we get v square remain v, differentiate with respect to u, minus remain u, differentiate with respect x plus y with respect to x. If you have a del z del y, the v is still the same, the u and v is still the same, but now is del y for x minus y, del y for x plus y. So these two parts, okay, you should get the answer is, okay, you try and do del z del x equals to 2y over x plus y squared, and del z del y you should get negative 2x x plus y squared. So del z del x, we found it, del z del y. But what is delta x and delta y? Is the change, okay, the change. So the delta x will be the change 4 1 over 10 minus 4, and delta y is 2.1 minus 2, we get 0.1. So, okay, substitute all this into the dz, 2y x plus y squared 1 over 10 plus, minus 2x x plus y squared, del y is 1 over 10. Now dz here, the change, the x and y is the original value of x and y. So here you need to substitute x equals to 4 and y equals to 2, the original one. So when you substitute this value, you should be able to get the answer is negative 1 over 90. So this is approximate change. You have the functions, you know the original xy, you know the increment, then you can approximate what is the change for z. So the question is, the second part, what is the exact change? So it's very easy. From the z, you substitute the original value x and y. You get the answer. Then you substitute z with the new value of x and y. You get the answer. So the exact change will be, take the value b minus a. This is the exact change. So you will get the answer is negative 1 over 90. That is a little bit different. Because this is exact, this is only approximate by using the formula. Okay? So this section is the last sections in chapter 16. Okay? The differential 16.8 is the last section for chapter 16. Okay? So we still have a few minutes. Okay, let's look at a little bit for chapter 17, the double and triple integral. Okay, we touch about the notations and a very simple one question for the double integral. Okay, so we if in calculus involve only single integrations, you have only one summations. Now you have for multiple integral, you have double sigma notation or triple sigma notations, where you now have three variables. Okay. So the simplest one, the double integral, will be you are integrate over a rectangle R. Okay. So now if more than one variable, if two variables mean your is in the 3D. So the region R here, it can be in any shape. The simplest one will be the rectangle, because all you will involve is only value. So this is the simplest one. Okay, let's move on first, then we'll go back to this example. So you may find the volume of a solid when, okay, by using the formula double integral. So it's a double integral. This is the functions and over the region R. Okay, so from graph, it's like this is the fxy. Is bounded by the region R. You are actually finding the volume of this solid, which this is like rectangle, is like a cuboid, but the up is covered by the fxy. Okay, so your fxy here. Okay, so this is up. It is covered, bounded above by fxy. The R here will be when you project to xy plane. Okay, your x and y plane. Okay, you get the region R. So when you going up, and then you will get the solid in 3D. So the formula to find the volume is double integral, the functions that is bounded above, and over the region R is the one that project to xy. So the same formula, if you want to find the area, is the function here will be 1. So it means you are actually finding this area. Because multiply with 1. The fxy is 1, that means you are having the 2D at the xy. So remember the formula. To use the double to find the volume using double integral, v equals to the double integral, and we put dA, and then this is the functions, and this is the R. If we want to find area using double integral, that means double integral the dA, but now this is 1 and over the region R. Okay. And dA here is can be dx dy, can be dy dx, and when you dx dy, the limits here is different from the when you use dy dx, but it will refer to the same region. Okay? It will refer to the same region. So the region here just now is the rectangle. Okay, but there is also the region R is irregular shape. Okay, it can be any shape, but maybe represents it with a function. So what does it mean here? If over the region here, it's still the same. fxy is the up, cover up. The omega here will be the region. It can be irregular shape like this. Okay, never mind, like this. Then when you project up, and then it's covered by this surface, then the solid V for this solid will be this solid 3D. Okay, so you may divide into small region but non-overlapping. Okay, and the mean value theorem. Okay, so let's look at how do we solve the double integral. This is the simplest one with the values number. Okay, so the proper way to write, to solve for this kind of double integral is the dy and dx. We will do step by step. The integrations for inner is for dy. The 0 to 3 is for dx. Okay, so it means this is for y because of dy, and this actually the value for x. So when you solve, although we are solving the inside the inner integral first, but the outside here, don't forget to write it. So normally when we solve, we will maintain 0, 3 and dx. Now we solve for the integrate these functions with y. When integrate with y, assume x constant. So x squared is a constant. Y, integrate y, we get y squared over 2 minus 2x, like a constant. Integrate y, we also get y squared over 2. And substitute the value is for y. Y negative 2 to y 0. Okay, so all these maintain. We didn't touch the dx first, but you need to write. Okay, so now what does it mean? Okay, we substitute. This can be simplified. We substitute y equals to 0 minus substitute y equals to negative 2 into the functions. So when y 0, 0 minus y 0 is also 0. When y negative 2, negative 2 square is 4. 4 because of 2, you have 2x squared. Minus, substitute y negative 2, we get 4, 4x. Okay, so I can put it, simplify, 0, negative, plus. So I have 4x minus 2x squared dx. And this is for x. So this is simple. Okay, 4x squared over 2, 2x cubed over 3, and now this is for x. And simplify, you have 2x squared minus 2 over 3x cubed. Again, okay, so substitute the value, you get 9, 2 over 3, 27, minus, substitute x 0, you get 0 minus 0. So 18 minus 18, you get the answer is 0. Okay, so remember we are doing inside first, but the outside here you should remain. Write it. And this is dy, this is for y. dx, this is value for x. Okay, so I think I will stop until here. Okay, and this is the reminder for assignment 2. Okay, the deadline is 29th of March. Okay, so don't forget to submit your assignment on time. The questions you may download from the portal. Okay, I think that's all for today's webex. Thank you very much for your attention.